All right, so this is the last video on ionic bonding, and that is to figure out, well, what kinds of ionic bonds, what kinds of charges can different elements make? So again, what makes an ion? It's how many valence electrons are either gained or lost to reach a noble gas configuration. So let's see if you can figure this out. Take a look at this aluminum atom here. What I'd like you to do is figure out how many valence electrons does it have? Take a minute, take a look at that picture, see if you can figure that out. So, as you look at it, remember valence electrons are the electrons in the outermost orbitals. So in this case, we say that it has 3 valence electrons. We've got 1, 2, 3. Okay, now what ionic charge will it have to become to get to noble gas configuration? Is it easier to gain 5 and have 8 in that outermost orbital, or is it easier to lose 3? And the answer to this is it's going to be an aluminum plus 3 ion. So when it's only plus 1 or minus 1, we just put the symbol. But if it's 2 or more, we always put the number to indicate how many electrons were gained or lost. So it's easier to lose 3 and be a plus 3 ion. Okay, so there's general rules of thumb that are easy to follow with this. Alkali metals always make ions with a plus 1 charge. They have 1 valence electron. You get rid of that, you're a plus 1 charge. Alkaline earth metals have a plus 2 charge. 2 valence electrons, get rid of the 2, you've got a plus 2 charge. As we skip over to group 13, the boron family, they have 3 valence electrons. You can get rid of those 3 and have a plus 3 charge. The carbon family has 4 valence electrons. It is just as easy, theoretically, to gain 4 electrons and have 8, or lose 4 electrons and have 0. So they could make ions that are either plus 4 or minus 4. Now, interestingly, carbon doesn't make ions all that often. It usually covalently bonds, but if it does ionically bond, it will be plus 4 or minus 4. And that actually depends on who it's bonded with. If carbon is bonding with something that is going to be more electronegative and steal electrons, such as oxygen, fluorine, and so forth, it's going to be a plus 4. If carbon happens to bond with something over here that's easily losing its electrons, then it becomes negative 4. The nitrogen family will take on a negative 3 charge because there are 5 valence electrons. It's easier to gain 3 than to lose all 5. The oxygen family has a negative 2 charge because they have 6 valence electrons, and 2 more gets to 8. The halogen family has a negative 1 charge because they have 7 valence electrons. Lose 1 more, or gain 1 more electron, you get to 8. And the noble gas family does not make ions. They already have full orbitals, so they're not going to gain or lose electrons. So as we look through the trend, it's quite easy to follow it. It is plus 1, plus 2, plus 3, plus or minus 4, then it's negative 3, negative 2, negative 1, 0. Now transition metals are a group of metals that can have a variety of ionic charges. They can actually go anywhere from a plus 1 to a plus 7, and it really depends on where they're at and what element it is. We call them transition metals because they can have multiple charges. The same element could be plus 2, plus 3, plus 5, depending on the element. And so we call them transition metals because they can transition between different ionic charges. However, they're always positive. Metals, all metals, have positive charges. That's one of the things about being a metal. Now, sometimes there are groups of atoms who get together and as a group have a charge. We call that a polyatomic ion. Poly means many, and so it's many atoms that together as a group have a charge. So they're actually bonded covalently together, but some of the atoms have gained or lost electrons to take on a charge. And so one example is sulfate. Sulfate is SO4. It is a group of 5 atoms, 1 sulfur and 4 oxygens, who as a group always have a -2 charge. There is a list of polyatomic ions on the chemical reference sheet that I've given you. Here is just a partial list of those polyatomic ions. And so these are some of the names that you're going to see on here, like carbonate and nitrate and phosphate and sulfate. And so these polyatomic ions have more than one atom. It could be as little as 2, or it could be as many as 5. You'll notice several of these, like phosphate and sulfur, have 5. It doesn't matter exactly how many they have. It's a group of atoms that have a charge together. Negative anions are by far the most common, but there are a few positive or cations that are polyatomic. The most common one being ammonium. The other thing you'll notice about this is almost all of them have an oxygen involved. There's a reason for that, and we'll get into that later on in a lesson. But you'll notice all of these polyatomic ions, not counting the cyanide that's right there, have oxygens, often many oxygens. So we'll go into that in more detail. For now, if it's a group of atoms who go as a group with a charge, we call that a polyatomic ion. So here's an example of something that can happen where you've got acetic acid, that's vinegar, and acetic acid interacts with water molecules. So you take this acetic acid, you dissolve it into water. What will happen is that the water molecule will be attracted to this hydrogen right here and will actually pull it off of the acetic acid. The net result is that the water molecule becomes H3O with a positive charge. It pulled the hydrogen off but left the electron. Now we've created the hydronium H3O plus ion. What's left behind is the acetate ion with a -1 charge, and that electron was left behind right there with that oxygen. And so this is the acetate ion.